Hi everyone, I'm Marie and today we walk through kinematics motion in two dimensions. In this presentation, we'll introduce and define motion in two dimensions, see the characteristics of two-dimensional motion, projectile motion, horizontal and vertical components, equations of projectile motion, trajectory and motion graphs, worked examples, applications of two-dimensional motion, key points to remember, and then end with the references. Let's get started. Introduction and definition. In many real-life situations, objects move in a plane rather than along a straight line. Their motion involves two perpendicular directions at the same time, the horizontal and the vertical directions. Kinematics in two dimensions helps us analyze and predict the position, velocity, and acceleration of such objects without considering the forces that cause the motion. Definition. Motion in two dimensions is the motion of an object in a plane where its position changes in both the horizontal x-axis and vertical y-axis directions at the same time. Here's the key idea. The object path is a curve called a trajectory, resulting from the combination of horizontal and vertical motions. Why it matters. Understanding two-dimensional motion allows us to explain and predict the motion of objects in many everyday activities and natural phenomena like kicking a ball, water from a fountain, fireworks, throwing javelin, etc. We move to characteristics of two-dimensional motion. Two-dimensional motion is unique because of an object moving simultaneously in two perpendicular directions. This gives it a special characteristics. 1. Two perpendicular directions. The motion occurs along two mutually perpendicular directions, the horizontal and vertical directions. 2. Independent motions. The horizontal and vertical motions are independent of each other. 3. The trajectory. The combination of horizontal and vertical motions produces a curved path called a trajectory. Same time of flight. The time taken for the object to complete its motion is determined by the vertical motion only. Constant acceleration. In most cases of projectile motion, the only acceleration is due to gravity, acting downward with constant value g. Some key points to remember. Horizontal motion has approximately zero acceleration. Vertical motion has constant downward acceleration. The combination of these motions results in a parabolic trajectory. Below we have a diagram or a graph and some brief explanations for better understanding. We move to projectile motion. Projectile motion is a motion of an object that is launched into the air and then moves under the influence of gravity alone, neglecting air resistance. After being projected, the object follows a curved path called trajectory. Main characteristics: launch into the air. The object is given an initial velocity and an angle to the horizontal. Gravity acts downward. The only force considered is gravity, which causes vertical acceleration. Horizontal motion is uniform. There is no acceleration horizontally in ideal condition. Path is parabolic. The combination of horizontal and vertical motions creates a parabola. Symmetry when landing at sea level. If the object lands at the same height from which it was launched, time of ascent is equal to time of descent. So it means if an object is launched at the same height, time of ascent is equal to time of descent. There's a typical trajectory graph besides and some explanations too. Key conditions of ideal projectile. Negligible air resistance. Air resistance is ignored to simplify the motion. Same launch and landing level. Often assumed to be at the same height to simplify analysis. Constant gravity. Acceleration due to gravity is constant near Earth's surface. We move to horizontal and vertical components. In two-dimensional motion, the initial velocity of a projectile can be resolved into two perpendicular components, horizontal and vertical components. Resolving initial velocity. If a projectile is launched with an initial speed v at an angle theta above the horizontal, the initial velocity can be resolved into horizontal components along the x-axis and vertical component along the y-axis. Down are the component equations we will use in calculations, where VR is the initial speed, theta launch angle above the horizontal in degree, VOX initial horizontal component in meters per second, VOY initial vertical component in meters per second. With vector resolution diagram besides for explanation to better understand what we're talking about. Key idea. The projectile's motion is the combination of uniform motion horizontally, uniform accelerated motion vertically, and these two independent motions together produce a curved, which is the trajectory. Note, the horizontal and vertical components are independent. Studying them separately helps us analyze and predict the motion easily. We move to equations of projectile motion. Projectile motion can be described using equations derived from the independent horizontal and vertical motions. These equations allow us to find position, velocity, and time at any point of the trajectory, neglecting air resistance. So here we have all the equations and their names, how they will apply it. So it's really important to understand this part. Very important because we use them in calculations, and this is summary of key equations. Beside, we move to a trajectory and motion graphs. The motion of a projectile can be understood clearly by explaining its trajectory and the graphs of its horizontal and vertical motions. Key idea: horizontal motion is uniform, vertical motion is uniformly accelerated. Very important. For a projectile launched with speed v at the angle theta above the horizontal, the path is parabolic. Key features: starts at the origin, rises to a maximum height where Vy is equal to 0, symmetrical about the line through the minimum height, lands back on the horizontal at range R. Here are the graphs, all the graphs which explains for parabolic, vertical, horizontal, and below this is summary of all the graphs, so it will be easier to understand. But remember, the combination of uniform horizontal motion and uniformly accelerated vertical motion produces a parabolic trajectory. We move to worked examples. Here are some worked examples with all the solving, the answers, so we will better understand what we're talking about because there is no understanding with no examples. Yeah. And here's a key takeaway. Projectile motion combines uniform horizontal motion and uniformly accelerated vertical motion to produce a parabolic trajectory. The equation above allow us to predict key equations of the motion. We move to applications of two-dimensional motion. Two-dimensional projectile motion appears in many real-life situations. Understanding its principles help us analyze, predict, and improve performance in sports, engineering, technology, and daily activities. So, ideal conditions assumed because they are not really real. The assumptions: there is no air resistance, uniform gravitational field, object travels as a particle. So here are the applications. As we can see, there is defense and military, used for engineering, in nature like fountain, and technology. So it's very important to understand motion in two dimensions. And we need to note that physics is not just about formulas, it's about understanding the world that surrounds us. So we need to keep exploring our environment because that's physics. Then we move to key points to remember. 1. Motion in two dimensions combines horizontal and vertical motion. 2. Horizontal velocity remains constant, ignoring air resistance. 3. Vertical motion is affected by gravity. Gravity is acting downward. 4. The trajectory of a projectile is a parabola. 5. Horizontal and vertical motions are independent of each other. 6. Projectile motion has many real-life situations. You can just imagine a boy kicking a ball. That's an example of projectile motion in its real-life situation. Then we end with the APA reference. So all references are formatted according to the APA 7th edition guidelines, so you'll refer to this for further studies. Thank you.